Hey guys, want to build a robot? Welcome back guys! This video is a part of our series all about the new Rover, and in this video we're going to be covering Chapter 4, how to program the motors of the Rover.
The Rover has 4 motors, with each side wired together, powered by 2 motor driver chips. Now, the motor driver chips we use on the Rover are known as the DRV8871, and they are awesome. Super powerful, really easy to program. And so we're going to start off with this very first example, just learning how to program the right side of our Rover. Alright, so our goal with this first bit of code is just to test the right side of our Rover. And so you can actually find this in project number 5 on the ebook, or on the flash drive that came with your kit. This sample code is called right motors, and the goal is to control both the speed and direction of the right side of our Rover. Now, at first glance, this might look way more complicated than some of our other code, but I promise if we break down each of the steps individually, it's really not too bad. Now, one of the first things we see is a pretty strange looking library file. Now, believe it or not, this library file is actually already built into Arduino whenever you add the ESP32 board files. So thankfully, we don't need to add it the same way that we did with our other library files. And all you need to know right now is that this library file will help us create the PWM signal that we need to turn on our motor driver. Now, the motor driver that we're using on the Rover is known as the DRV8871, and it is an awesome little motor driver. One of its coolest features is that you can control both speed and direction using only 2 variables. In this case, input 1 and input 2. We have input 1 is hardwired to pin 13, and input 2, or in2, is hardwired to pin 12 on our ESP32. What's cool about only having 2 variables here is that I can control both speed and direction. Now, the PWM signal that I generate, that will control the speed of my motor. But if I send that PWM signal to input 1, my motor will spin in one direction. But if I send that PWM signal to input 2, my motor will spin in the opposite direction. Now, the void setup is where things start to get a little bit crazy. We see some commands that we definitely haven't seen before. LEDC setup. Now, in reality, this is referring to LED channel, right? So it's an LED channel, and I don't really like that definition. I wish it was PWMC setup, because that's what we're doing. We're setting up a PWM channel. So if you remember back to the buzzer, we used PWM channel number 0. And there are 16 that we could use. So in the previous example, we used channel 0 for the buzzer. In this case, we're going to use channel 1 for input 1 on our motor driver. So this command that sets up our PWM signal has 3 bits of information that goes with it. The first is the channel that you want to set up. In this case, we're setting up channel 1. The second is the frequency. Now in this case, we're using a frequency of 30,000 hertz, and that might be new information for you, right? If you've never used this kind of stuff in programming, that's totally fine. All you need to know right now is that 30,000 hertz is a frequency that plays really well with our motor drivers. The last bit of information has to do with the resolution. In this case, we're using 8-bit resolution. And all that means is what our motor drivers will take as full speed or no speed. So in this case, 127 is half speed and 255 is full speed. And we set up that range of numbers by setting up the resolution. So 8-bit resolution goes from 0 to 255. The second line in our void setup attaches a pin to the PWM channel that we just created. In this case, we're attaching input 1 to channel 1 that we just set up. Now, the second half of the void setup is doing the exact same thing. It's setting up PWM channel 2 at the same frequency, the same resolution, but this time connecting input 2. Now, the void loop is where we actually tell our motors what to do. So in this case, we do this by creating a PWM signal on our channel. And so we're taking channel 1, which is connected to input 1, and sending it a PWM signal of 127, and that is half speed. So this first line of code in our void loop tells our motor to go half speed forward. Now, it's impossible to have a motor spinning forward and backward at the exact same time. And so that's why if we have a signal going forward, we have a 0 signal going backward. Therefore, the motor spins forward. Now, if I want that motor to go full speed, That's as simple as switching the 127 to 255. In this case, 255 means full speed. I still have 0 speed going backwards, and so my motor will spin for 2 seconds at full speed. Now, if I send a 0 signal in the forward and backward direction, then the motors stop. Finally, if I set 0 for forward, but put 127 for backward, then my motors spin backwards. And we can do the exact same thing we did up above by setting 0 speed forward and then 255 for full speed backwards, again for 2 seconds. And so this is all we need to control the speed and direction. And again, we don't have to use 127 or 255. We could use any number in that range. And so we can actually get pretty accurate. So in this example, we control both the speed and direction of the right half of our robot. Once you have this written down and ready to go ahead and upload it to your rover, and let's see if it works. If everything went as planned, you'll see the right half of your robot spinning forward and backward, alternating between full speed and half speed. Alright, so we have the right half of our robot working. It's time to add in the other half. And one thing that's so awesome about this is it's really easy. You know, our code is now going to be twice as long, but that doesn't actually mean that it's twice as complicated, because really we're just duplicating the same code with different input pins. So in our book, this is project 6, and you can find this sample code as all 4 motors test on your flash drive and in the book as well. And if we take a look, we really have a lot of the same stuff. Up top, above the void setup, we now have 4 input pins because we're messing with 2 different motor drivers. Now on the rover, we have 1 motor driver per side because we wire the right motors together and the left motors together physically. In this case, inputs 3 and 4 are hardwired into pins 16 and 17 of our ESP32, and they're going to work just like the right motors. In the void setup, we need to add in 2 more PWM channels. In this case, we're going to set up channel 3 and channel 4, but we're going to set it up in the exact same way. We have the same frequency and the same bit resolution. We're also going to make sure that they are attached to input 3 and input 4, the variables that we added. Okay, now in the void loop, this is really important because we saw that we need 2 lines of code to drive the right side forward. And what's awesome is driving the left side is just as easy. So you see that if we have the exact same thing happening on the left side, and we have these 4 commands, this is all we need to drive the whole robot forward. So my pattern to drive the robot forward is 255, 0, 255, 0. And what's awesome is, you know, forward is the opposite of backward, right? And it sounds kind of silly to say, but in terms of software, it's just that simple. Because driving the robot backwards is 0, 255, 0, 255. And what's awesome is now that we're driving both sides of the robot, we can go ahead and talk about how to make the robot turn left and right. This will be really important when we're trying to build out our wireless communication code with our Bluetooth app and our PS3 controller. So if 255, 0, 255, 0 was forward, and 0, 255, 0, 255 was backwards, then left is 255, 0, 0, 255, and right is 0, 255, 255, 0. Believe it or not, this is everything that we need to start to build out our whole robot code. You know, now that we know what forward, backward, left, and right is, we can add in sensors. So drive forward until the distance sensor gets under 10 inches, or go forward whenever I press the forward button on my Bluetooth app, or as I move the joystick left and right, drive left and right. There's so much stuff we can do with this. And so let's go ahead and make sure that everything's working, and let's upload this code to our rover to make sure that in fact the robot is driving forward for 2 seconds, backward for 2 seconds, left for 2 seconds, and right for 2 seconds. If you see all 4 wheels spinning, then your robot is working and you're ready to move on to the next chapter, all about wireless communication.